Calculus kids, welcome to week 7, Monday with Dr. Callahan. I hope you guys had a good weekend. Go ahead and pause the video and get started on your warm-up log. Keep in mind that this is week 7, Monday, and your warm-up log is due on week 9, Friday. So after this week, you have fall break, and then after fall break is week 8. After week 8 is week 9. So that Friday is when this is going to be due. All right, let's go ahead and go over the warm-up question here. And it says, find the equation of the tangent line to f of x equals x squared at x equals -5. So whenever they ask you a question for the equation of the tangent line, you could either use slope, point slope form, or y-intercept form. What just happened here? Okay, here we go. So point slope form is y minus y1, y sub 1 equals m times x minus x sub 1. So in order to, I mean, you could have a preference of which one you want to use. I actually always like to use slope-intercept form. So you need to have the slope and the y-intercept. The first thing I probably want to do is find the slope, which I'm able to if I use the limit definition. So the limit definition is at delta x approaches a 0, f of x plus delta x minus f of x over delta x. So if f of x equals x squared, then you know that f of x plus delta x is going to equal to x plus delta x squared. And then if that is the case, I have negative f of x, which is just going to be a negative x squared. You would have to FOIL the first part. So that will give you a x squared plus 2x delta x plus delta x squared minus the x squared all the way over delta x. You are able to cancel the x squared, so that's gone. Factor out the delta x, you have 2x plus delta x. Now that the delta x can be eliminated, you can now apply the limit as delta x approaches to 0. So then that becomes a 0. So your f prime of x is going to equal to 2x. Still doesn't tell me what my slope is, but it does give you the point of -5 for x. So f prime of -5 is equal to -10. And that is my slope. I'm still missing the y-intercept. So in order to find the y-intercept, you will need to have the y value and x. You do know that x equals -5, but I don't know what the y is. But I can go ahead and use the y if I put in -10. Or, hold on, use the wrong equation. I could find a y value if I go ahead and plug in -5 there. Because f of -5 is -5 squared, which is 25. And that is my y. So now that I have my slope, my x value, and my y value, I can now proceed on to finding the y-intercept. So y equals mx plus b. My y value is a 25. M is a -10. X is a -5 plus b. So 25 equals 50 plus b. If I subtract 50 on both sides, b is -25. So my equation is y is equal to -10x minus 25. And that is my answer. Today, I am going to show you guys a shortcut, which is a second method of finding the derivative. So then rather than going through the limit definition, which can be very tiresome and strenuous and very long, we have a shortcut that you could probably do in 2 seconds. And that's called the power rule. And we're going to talk about that today. Okay, let's go ahead and move on forward. Up to this point, any of the quizzes that you have done, if you're not satisfied with the score, you're welcome to do a quiz correction or assessment correction. The template is on the Google Doc, and there are several templates. You can pick whichever one you would like, and once you complete it, for each of the questions, I'll give you 50% of the points back. This is an example of that from a previous student, so you can see that as an example. All right, let's go ahead and take a look at what we're going to talk about today. So today we're going to talk about the slope of a tangent line. We're going to go ahead and learn how to draw f prime of x without a graphing calculator by using information from f of x. And I'm going to have you guys do a little bit of a group work. It says, please read the summary notes and practice on the 5 examples. There's a link right there with a capital P or capital Q, capital P, capital A, and oops, if you go ahead and click on that, and it's not wanting to click on this, come on. Okay, fine, don't click on it. Let's see. How do I get out of this thing? Okay, let's try something else. Hold on a second. Okay, here we go. Click on that. It's going to take you to this page right here. There are 5 examples, and here are the notes on the power rule and constant rule. So you can go ahead and take a look at this. Here are the notes, and go ahead and practice with them if you need it. Then I'm going to have you guys do a little bit of group work on a free response question that actually features today's objective, and then have 2 calculus puzzles. The first one is going to use the first method of finding f prime of x, which is the limit definition theorem. What did the turtle say when he handed a question? And then after I show you guys the power rule, you're going to use that for method number 2 of finding f prime of x, and that puzzle is on why do derivatives never grow old. So 2 different skills. First one, the limit definition. So it's the one where x approaches, where delta x approaches 0. And the second one is you're just going to use the power rule, which I'm going to talk about today. As always, with after school tutoring, I do have my own office hours on Zoom. And if you go to your MS team, there is a tutoring link, and those hours actually changes week from week. I'm also available on Saturday and Sundays. If you need assistance, I can just send you a link to Zoom, and I can go ahead and show you and answer whatever question you might have. So check on MS team. So this is your guided notes for today. So please turn over to week 7, Monday, on your white packet. Here are a little bit of textbook work that you can go ahead and refer to if you need some additional practice. This is one of the puzzles. This is the one that we're going to use to draw f prime of x using f of x without a calculator. And then this one is with method 2, so with the power rule. And then here are the 2 questions, the free response questions that were featured, on some of the free response questions in previous exams using the limit definition. So up to this point, we talked about the 2 points. How do we get from the limit definition to, or how do we get from the 2 points of a equation for slope to the limit definition? So today we're going to talk about 2 methods of finding f prime of x involving square roots. The first one is with a limit definition. The second new one that we're going to go over is called the power rules. And there's one stipulation with the power rule, and that is you cannot have a negative exponent. Like if you have x, then -3, that's a big no-no. You want to change that to a positive. So we'll take a look at that. This is your guided notes that you should have in your notebook. We're going to go over these 4 examples, so make sure you find this. And we will be doing 4 examples using both methods. And actually, it's really just 2 examples. The example 1, they're exactly the same, except we have method 1 and method 2. All right, so let's go ahead and use the first method, which is a limit definition, to find the first question here. So if I were to do that, x plus delta x is going to give me, you're going to replace that x with x plus delta x. And then you have a minus f of x. So that's going to be a minus square root of x over delta x. If I were to apply the limit definition right now, it will become a 0 in the denominator, so it wouldn't work. So you're going to go ahead and multiply by the conjugate, top and bottom, because you're pretty much multiplying by 1 then. And then you're going to FOIL the top. When you're foiling the numerator, your first is just going to be x plus delta x, because the square root cancels. So there is f for first. Then you're going to have your outer. Your outer is going to give you and I'm just going to write on the side over here, a square root of x times square root of x plus delta x. And then you're going to have your inner, which is going to be a minus square root of x times square root of x plus delta x. So they basically cancel. So I'm not going to put it as part of my equation. And then you have your last. So you'll have a negative x all the way over delta x times, and you don't want to distribute it because you want to keep the delta x by itself. So then I get to cancel the x, the delta x, so I only have 1 on top now. Let's go ahead and apply the limit definition as delta x approaches 0. Since you cancel the delta x on the bottom, you're not going to have a 0 in the denominator. So we have a 1, that becomes a 0, 2 square root x, and that is my f prime of x. And then if you move a little bit further to find the equation of the tangent line, it's given to you a point right there. So you can do f prime of 4, which is equal to 2 square root 4. Square root of 4 is a 2. So your slope is 1 over 4. Now to find the y-intercept, you have y equals m times x. And I would like to give that to you, except I can't put my eraser. There we go. Times x plus b. So 4 equals 1/2 plus b. That means b is going to equal to 4 minus 1/2. Now the 1/2, you will have to have a common denominator. So the 4 will become a 8 over 2, which is a 7 over 2. Y equals 1/4 x plus 7 over 2 is your equation. So that's the old way of how we would find the derivative using the limit definition. Now, you guys have matured since then, and so we're going to go over the second method. And the second method is going to be with the power rule. Now, with the power rule, there are 2 conditions that you have to meet. There's absolutely no square root, and as a matter of fact, if you have a square root of x, you will have to convert it from radical form to exponential form, which means going back to algebra 2, that will be an x, and remember, it's always power divided by root. Your power here with the x is a 1, so that's a power. Your root here is actually a square, so that's a root. So you will write this as x to the 1/2. So you have to convert it to this form before you even apply the power rule. And also you cannot have a fraction. So if I have 4 over x to the 3rd power, going back to algebra, you will move this up. So you have 4x to the -3 or -3rd power. So those are the two stipulations. And if you don't have either of those in your way, then apply away with the power rule. So here we go. Let's go and try the power rule. The power rule is that the derivative of x to the power, okay, n stands for power, is going to be, you need to move that power down in front of the x as a factor, and then it's going to be that n power minus 1. So you will have n times x to the n minus 1 power. So looking at this example right here, here have f of x equals a square root of x. Immediately, I know that I cannot have a square root, so I'm going to transfer from a radical form to an exponential form. And then when I apply the power rule, what ends up happening is that my 1/2, which is the n, comes down in front. And then I have to subtract the 1. So I know if I subtract the 1, I will need to have a common denominator. So to save some time, I'm just going to put a minus 2 over 2, which is still a 1. So then 1/2 minus 2 over 2 is a negative 1 over 2. And that is my answer. But remember, I don't want to have a negative exponent. So going back to algebra, you're going to move this entire x down to the denominator, which will give me a positive 1/2. And if I convert this back into a radical form, this will be my slope. And if you recall, that's exactly the same answer that we received when we used the limit definition, except this took us significantly less work and less time. So why we wouldn't want to use the slope of a tangent line formula, let's go ahead and take a look at the next example. Now with this one, you could use the old method, which is a limit definition, but this is one that's going to take a very long time. So if I were to do f of x plus delta x, or remember I also told you that it could be used simultaneously with h, h is fine too. You would have x plus delta x plus 1 over x plus delta x. So that's just f of x plus delta x. Now negative f of x is going to be minus x minus 1 over x all the way over delta x. Now I don't know about you, but I really wouldn't want to simplify that because you will probably have to find a common denominator with these two fractions and a common denominator with these two fractions. And then once you're done with all of that, you would have to combine these fractions together in an effort to eliminate the delta x. And it's just such a headache. I wouldn't want to do it. But if you do want to try it, this is my work right here. You can pause the video and take a look. And, you know, I hate to tell you, but it continues. I'm like, we're even splitting something here, which I'm like, that just doesn't look very pleasing. Or what you can do is you can go ahead and use the second method, which is simply just using the power rule. So this is what I have. F of x is equal to x plus 1 over x. No fractions, so I would need to write x plus, move this one up, x to the negative 1 power. So then when I find the derivative of this, what is the derivative of x? This is where the constant rule happens, okay? The constant rule basically says that anytime you find the derivative of a 6x, let's say for example, anytime you do something like this, it's just going to be 6. If f of x is equal to x, f prime of x is going to be just 1. And I know you're like, well, why is it just the coefficient of this? Because if you think about it, if you're looking at 6x to the 1 power, what you're going to do with the power rule is you take that 1, bring it down here, so it's 6 times 1, x. And then you have to subtract the 1 and the exponent, so 1 minus 1 is a 0. Well, what is x to the 0 power? A lot of my freshmen say 0, but that's not true. If you plug into your calculator, it's actually 1. So 6 times 1 is just 6. And that applies to any number, like 5x is 5, 100x, the derivative is 100, because it's always just going to be multiplying 1 to the leading coefficient. So then looking at this, what is the derivative of x? It's 1. What is the derivative of x and negative 1? This one you have to put a little bit of work. So you take the negative 1, bring it down, so you have a negative 1 times x, make sure you minus 1 here, to the negative 2nd power. So that will give me a negative 1 over, bring down the x to the bottom because you do not want to have a negative exponent, x squared. And that right here is your f prime of x. A lot easier than attempting to merge 2 of the fractions together and then merging 1 more of the fractions together. So this is a much easier process. Okay, so we're done with that. Now what I want to talk to you guys about is drawing derivatives. So how would you graph f prime of x if I give you f of x without a graphing calculator? There are 2 rules. Number 1 is when the slope of f of x is positive, f prime of x is above the x-axis. When the slope of f of x is negative, f prime of x is below the x-axis. So because you're dealing with the x-axis, some of the hints I would suggest is definitely look for the max and min points for the positive and negative slopes. And let's take a look at this. So look at the relationship between the black line, which is f of x, and the blue line, which is f prime of x. Remember, look for the positive and negative slopes. So here, from point 1 to point 2 here, which I think one of the things I asked you to do is look for the max and min on y of x, or f of x. Here is a minimum, and here is kind of a maximum. It's not quite, it's actually called a saddle point, which is a term that we will learn in Calculus 2. But the reason why we look for the max and min on this equation, on the black line, is because that's when the slope changes. You know, when you have a minimum right here, your slope is 0 because the tangent line has a horizontal line, it's a horizontal slope, okay? So the slope is 0. Obviously, when you go to the right side of the slope, or right side of this point, your slope changes from a negative to a positive. So given the fact that this side right here is a negative slope, so negative slope, that means your f prime of x is below the x-axis. And if you take a look at this blue line, it is below the x-axis. And notice that when I finally start climbing on top of the x-axis, it is at this minimum right here. So once again, let's try this one more time. So this right here is a negative slope, which means your f of x has to be below the x-axis, okay? Then, if you take a look at the continuation of this, when the slope transfers from a negative to a positive to the next point, that's a positive slope. So now you have a positive slope, which means your f of x is going to be above the x-axis. So looking at this part right here, from this minimum to the next maximum, it is above the x-axis. So that's kind of the relationship of how to draw f of x, f prime of x from f of x. And the only way to get better at this is if we actually just keep practicing. So what I want you guys to do is take a look at this right here. This line that I am going to color in purple, or no, let's do a different color. Let's do green. This line represents f of x. So pause the video and you could trace it with your fingertips to see what f prime of x will look like. First thing I want to do is that I want to identify the points when the slope is 0. Okay, so ID when slope equals 0, and that's generally where the max and min is. So there's a minimum, here's a maximum at 3, minimum at 4. Then you want to identify positive or negative slopes. So from this beginning to this point, to the minimum, or I'm sorry, yeah, minimum, the slope is a negative slope, which means it is going to be below, f prime of x is below the x-axis. So I'm just going to go ahead and draw. And your picture can look a little bit different than mine because depending on how you attempt to draw it, I'm just going to say it's going to be below, okay? Because remember, this is a max and min. I'm going to draw little dashes right here as well, so that way I know exactly where they're located, so I don't overdraw above or below. And notice it's definitely below the x-axis. Now let's continue. Now from the next minimum to the next point, notice it is a positive slope. So f prime of x is going to be above the x-axis. So then I'm just going to say it's going to go above the axis, but it has to meet by this point, because that's when the slope is going to change again, and you can't just keep going up in like midair and go, whoops, can't go below the x-axis. So it has to meet. All right, so then from the next maximum to the minimum, that is a negative slope. So now we are below again. And luckily I have my graph ending right at the x-axis, so it's gonna go below. But make sure, once again, you meet it up to the x-axis at the next point. And then the rest of this is just a positive slope. So it's going to be above. So here we go. And this is your graph. And that's how we graph a f of x to a f prime of x. So now what I want you guys to do is, this is actually in your guided notes. Go ahead and practice with this. These lines here are f of x. I want you to graph f prime of x. Here are some of the answers that I got. So yours might look a little bit different than mine, but and that's okay. So you can go ahead and take a look at it. If you kind of mess it up the first time, that's okay, because I gave you extra paper, like on this slide right here, so you can redo it. Okay, so now what I want you guys to do is take a look at the 2 questions on the free response. Give it a try. Free response are always by parts. You don't just have one direct questions. You generally have like part A, B, C, D, E, sometimes even all the way to G. And the hard thing about this is that it's really hard to get down to part C if you're not able to answer part B. But as we get closer to the AP Calculus exam, I will be telling you guys about strategies of how to continue on. Even if you don't know how to do part B, you should still be able to do part C, assuming that you know what part B is. And even if you don't know what part B is, guess an answer and proceed forward with part C, because you don't want to go, great, I got stuck on part B, now I can't continue my question for part C, D, E, F, G. And I will tell you those strategies as we get closer. Now, also what I want you guys to do is these 2 calculus puzzles. Give it a try. One, I want you to use this one using the limit definition, which is the x or the delta x approach 0. With this one here on the left side, use the new one that we just learned, which is the power rule. And then these are the 5 examples and the 5 practice problems of the constant rule and the power rule. I would suggest you practice with these examples. And then if you're ready to check your work, I have the answer and steps right here, capital Q, capital P, capital A. And here are your 2 answers for the free response questions. And that is basically it, you guys. So I hope you guys are having a great Monday, and I hope to see you guys next time for Tuesday. Take care.